All right, we're going to talk about section 6.17, which is very similar to 6.16 actually, but we're just going to be kind of looking in the opposite direction. What we're going to be talking about here is markups and discounts. And these are both things they're both things that people use in business when they're selling things, because if you mark up something, that means that you can earn a profit on it. So if I mark up something, I would have something for $10, and then I would sell it for $15, and then I can pocket the extra money. Now, a discount is something that if I was selling something at $10, but it was going to lose its value soon, or I was trying to get rid of its stock, I could then sell it for $5. So quite simply, markups are where the price go up, and discounts are where the price go down. Now I want to show you a couple tricks to do these problems a little bit easier. So say for example, if we take a let's find one of their examples. Camera store, and they buy a camera for $159, and then they mark it up 10%. What is the final price, right? The final price. Well, we're going to use a very similar formula that we used last time, and we're going to look at the amount of change equals the percent change times the original amount. And we're going to look at this, but then as soon as we do this, I'm going to show you a little bit of an easier way to do this. Okay, so then I'm going to just put 10% times the original price, which was $159. 0.1 times 159 is, it should be 15.9. There's our markup. And then this is the markup. That means I'm increasing the price. So then I'm going to have to add this back to my original. So I have 159 plus 15.9. which is going to give me a total price of $174.90. Because if I'm doing money, I can usually add on that tenths, even if it's a zero. But let me show you how to do this problem in a slightly easier way that just saves us a step. So we had $159, and markup is 10%. So if I look at these using variables, I can really write this out as my price with this markup affecting the price again. And if I could write out what I did up there, I really took my discount. So I took my price times this 0.1, and then I added it to my original price. And if I were to write this out, I could write this as 0.1x plus x. And I can actually add these two together, because if I have 0.1 of something and a whole of something, I can really say that I have 1.1 of something. So this would give me 1.1x. So an easier step to do this is that now, instead of adding something later, all I have to do to find the markup is put my dollars back in. So I can just do 1.1 times 159. And when I put that in my calculator, sorry, let me grab it. 159 times 1.1, it gives me 174.9. Exactly what I had before. But this way, it saved me a step. Let me show a couple more examples and how I got to that point. Okay, let's look at this. We have a chair, example 2. We have a chair that is $199, but it's marked for 15% off. Okay, so if I think of the whole price of the chair as 1x, and I subtract this as a decimal, this is as a decimal, of course, goes to 1.15, I can think of, well, the total price now is 1 minus 0.15 of the total price. This is equal to 0.85. So I can simply write this whole thing as 0.85x, because I'm really paying 85% of the total price, because 15% of the price I'm not paying. If I were to draw a little diagram, this is what I'm paying, 85%, and not paying due to the sale. So now it's easier. So I can just put in 0.85 times 199 right into my calculator to see what I've got. 0.85 times 199, which gives me 169.15. And it's going to give me the total like that, much easier than doing the additional steps. I find that it's also easier to do this in my head. Okay, let's do one more. Let's see, we have a shirt, a $15 shirt on sale for 30% off. Okay, so if I think of X being $15, the real question is, how much of this shirt am I going to be paying? Well, this is 0.3. 1 minus 0.3 is equal to 0.7. So I'm really going to pay 70% of this total shirt. So I can write 15 times 0.7, which is also 70%. So I can put this into my calculator. We've got 15 times 0.7, which is going to give me $10.50. If you feel like you get it and you understand my method, go ahead and go on. I'm going to do two more examples just because this can be a little bit weird. Example 4. Okay, let's take a look. Okay, sometimes we use this doing markup. Let's take a look at number 1 on the homework. It says $19, and pretend that it's marked up 20%. Well, if it's marked up 20%, I'm actually going to be paying more than the total price. So if I think of my total price as X, this is going to be really plus 0.2x, because this is 20% of this 19 that I have to add back into it. And if I write x plus 0.2x, I can really write 1x plus 0.2x. I can write this as 1.2x, or 1.2 times the price, because it's 1, which is the original price, plus 20%. So let's see what this total is. 19 times 0.2 is equal to, 19 times 1.2 is equal to 22.8. And that is not too bad. Let's take a look at the first example in the discounted section, which is number 11. That one says, discount the price 15%. Then find the new sale price, and our price is $55. Okay, discounted 15%. That means I'm going to be paying 1 minus 0.15, which is equal to 0.85. I'm going to be paying 85% of this total price. So I can say 0.85 times 55 should get me my price. 0.85 times 55 is going to give me 46.75, and that's going to be the price that I pay. I hope that makes sense, and good luck.